So thanks for coming by to see us talk. Thank you, CoreOS, for having us here. My name is Kevin Jones. I'm a sales engineer at NGINX, and this is Michael. He's an engineer here as well. He does integration to different platforms and various technologies. So he specializes in just learning about new technologies coming out and how NGINX and NGINX Plus integrate with those technologies. So what we're going to show today is basically how you can kind of load balance some applications using CoreOS. We here at NGINX really like CoreOS because it's got a full suite of applications that can easily deploy containers in a clustered environment in a distributed system. So all the links are going to be available on here. So if you guys have a camera now, take a picture. We're also going to show it again here at the end. But all the links to the slides, to the actual demo that we actually have on GitHub, which you guys can actually do yourself, and then some of the just general documentation of what we're going to be talking about today is all going to be available on there. So yeah, so our objectives. First of all, we're going to do a quick overview of what our deployment plan is going to look like in terms of what we're trying to accomplish using NGINX and CoreOS. And then we're going to do a quick overview of those features that we're going to be using in CoreOS, specifically etcd and Fleet. And then we're going to talk a little bit about service discovery. I'm sure a lot of you know what it is, but we're going to cover that. And how to use Fleet as an application deployment scheduler. And then we're going to obviously talk a little bit about NGINX and some of the features we're going to use, both with the open source version and NGINX Plus. And then we're going to tie it all together with the live demo. And then we're going to get on the party bus. So who's down? So what exactly is service discovery? I assume everyone kind of knows what it is. But really, it's a way to keep track of dynamically changing environment, right? Immutable infrastructure, stuff that's always changing. More so now than ever, we have to do that with Docker and Rocket and all these containers because we have services coming up, and dying, and whatnot. So we need a way to do that. It's used for tracking the IP addresses, port numbers, services, and then also tracking things like credentials, protocols, versions of the software, and other details. Really anything about a service, right, is meant to be kept track, right, in service discovery. So for the model that we're going to follow today, and the demo is using a Sidekick service discovery model. Where essentially what we do is we have clients connecting on an outbound NGINX instance running as a load balancer. In the demo that we're going to be doing today, we're going to be using NGINX Plus. You could use open source. With the demo, we're going to showcase some of our APIs that are in NGINX Plus that make it easy to orchestrate using etcd. And then we're going to use a service discovery process that sits alongside of NGINX as a load balancer. So it's actually a unit that's going to get deployed, and it's going to be available alongside NGINX Plus as a load balancer. And that's going to be talking directly to etcd. And then we're going to deploy 3 web servers just as backends, basically just serving NGINX. Same thing there. We're going to have for each particularly backend, we're going to have another Sidekick service discovery process that's running and constantly updating etcd. So essentially, when we're done with the deployment, this is what we want it to look like. We want to have a 4-core cluster of CoreOS servers. And we want to deploy NGINX on each individual unit separately so that we have a clustered distributed system, right, using NGINX. So the NGINX as a load balancer will be deployed on one cluster, and then the web servers will be deployed on 3 separate ones. Overlaying that, we're going to be using Fleet to do some of that deployment and manage those deploys. So why did we choose CoreOS? So other than CoreOS is sponsoring this event, but that's not why we did it. We actually really like some of the features of CoreOS. Specifically, it's an open source project, etcd. It's very easy to set up. It allows you to run services containers, stable and reliable update system, and it's secure. So in general, all of what CoreOS is really designed for for microservices and this new technology that we're getting used to, right, with containers. So it kind of has everything that we need in it. So most importantly, for what our demo is going to be showcasing today, is it's got built-in cluster management using Fleet. So Fleet is a way for you to deploy units across a cluster of CoreOS servers. And then it's got a built-in service discovery tool that's very powerful called etcd. So we're going to use that to keep track of all of the services. So Fleet, so Fleet presents your entire CoreOS cluster basically as one single init system. It allows you to schedule services or scripts or anything across an entire cluster of your CoreOS cluster. It also allows you to do containers on arbitrary hosts, and it allows you to basically distribute services as ephemeral units across a cluster of CoreOS machines. And you can also tell it to maintain a set number of instances that you want deployed and have it automatically reschedule on failure, which is powerful. And we're going to showcase a little bit of that today in the demo. It also comes with a really nice command line tool called fleetctl, which I think we've seen that a little bit today. Basically allows you to keep track of the actual machines that you're running and manage those right over the command line. Fleet specifically, this is kind of what a unit file looks like. And I apologize for the display, but got cut off a little bit, something with the resolution. So you can actually specify some special configurations to tell Fleet exactly how you want to deploy the application, right? So some of those that we're going to be doing today is conflict. It tells Fleet not to schedule more than one unit on the same machine. Environment file allows you to read in a set of environment files from a specified file. We're going to use that today. Execute start executes a command at the launch of the unit. Machine of tells Fleet to schedule the unit on the same server as the specified unit. And then you can also link containers together with binds to. And then execute stop will execute that command at the stop of the actual unit getting launched. And then after everything's done, you can tell Fleet to schedule the deployment after the specific unit has been launched. So etcd. As I said before, etcd is really useful for service discovery. It's got a reliable distributed key value system storage, so you can actually have etcd running on your entire cluster, and you can keep uptime of that state. The nice thing is it's written in Go, so it's very fast. And it also has a simple interface to interact with. You can interact with it over HTTP, or you can interact over JSON using a JSON, or HTTP and JSON, sorry. It's also secure. You can set up SSL client certificate authentication with it. And like I said before, it's very fast because it's written in Go. It does have a command line tool as well. So you can manage it over the command line, or you can manage it over HTTP, using the REST API. So as I said before, sorry about the slides. I got messed up. So yeah, so NGINX. So why did we choose NGINX for the demo, other than the fact that we work for them? Who here knows what NGINX is? Who's here has configured NGINX at some point in their life? All right. So NGINX is pretty awesome. It's a layer 4 and a layer 7 load balancer. So we're going to be using it to front our application and do a deploy with that. And then we're going to actually be running NGINX as a web server on the back end. So a lot of people don't know, but NGINX is a web server, a load balancer, a reverse proxy, and it does caching. So it does serve a lot of things. There's two different ways that you can operate this demo that we're going to be doing today. The one that we're going to be showing you is using NGINX Plus, which is our commercial version. But there is a valid use case to use what's called confd. Who's familiar with confd? Awesome. OK, so confd allows you to talk directly to etcd and keep track of your services and actually generate a configuration file for NGINX and issue a reload of that configuration file, all by watching etcd. So this demo could be accomplished using confd. For the sake of our demo and kind of to show some of the showcase of NGINX Plus, we're actually going to use our NGINX Plus API, which is it's an HTTP API that allows you to dynamically add and remove upstream servers over an HTTP endpoint. So we're actually going to be using that to manipulate those endpoints. Another thing that we're going to be using is health checks. NGINX Plus has active health checks. So basically, you have the ability to tell NGINX to reach out to an upstream server and verify that that server is healthy and that it comes back with a specific status code, as opposed to NGINX open source just does a default connect, and if it can't connect after a certain timeout, it will fail. So we're actually going to use proxy connect read and connect timeout of 1 second, and we're going to set the health check to interval every second so that we can quickly fail, right? If you were using open source, you could just set that fail timeout lower, and you should get a little bit more of a reactive check on your server by lowering the fail timeout and limiting the number of max fails as well. So yeah, so that's pretty much an overview of what we're going to do. Now we're actually going to do a live demo. I'll pass over to Michael.
OK, thank you, Kevin. So let's start. I have a CoreOS cluster that I run locally on this machine with Vagrant. And if I do fleetctl list machines command, you'll see that I have 4 machines in my cluster. So as Kevin told, we're going to launch several services. So let's start with the first service, the backend service. And let's see its template unit file. So what we do here is with exec start option, when the unit starts, it launches a container, which is our simple web application. But we also map the port 8080 on the machine to port 80 on the container. And because we're doing that, we also tell Fleet, using the conflicts option, not to schedule more than 1 instance of this unit onto the same machine. And let's look into another service, the backend discovery service in its template unit file. So the goal of this service is to register the backends in etcd. And the after option tells Fleet to start this unit only after the corresponding backend unit started. And the corresponding backend unit is the backend unit with the same instance name represented by the variable I. Binds to option links units together. So when the corresponding backend unit stops, this unit also stops. And machine off option tells Fleet to schedule this unit on the same machine as the corresponding backend unit. When the unit starts, exec start option launches not a container, but an inline shell script with an infinite loop in which we, using the etcd-ctl command, set the key in etcd. The key consists of the private IP address of the CoreOS instance and the port 8080, which is the port of the backend service container, every 30 seconds. And we also set the TTL value equal 40 seconds, so that if the machine with this unit goes down suddenly, the key eventually gets expired from etcd. OK, so let's launch 3 backend units with 3 backend discovery units. And I put those comments into the scripts create s.sh. So we're going to launch this script instead. So using fleetctl start command, we launch units. And as you can see, almost 3 units now launched. And what we're going to do, let's check what's inside etcd. So we're going to use etcd etcd-ctl command, etcd-ctl ls command, and check the services backend directory to see what's inside. And as expected, all 3 backends got registered in etcd. So let's deploy the load balancer now. And we do it with another service, load balancer service. So let's look into its template unit file. And when the unit starts, it launches a load balancing container. And it maps port 8080 and port 8081 on the machine to the same ports on the container. And using conflicts option, we tell Fleet not to schedule more than 1 load balancer unit on the same machine, and not to schedule the unit on the machine with the backend unit already running. And how does load balancer learn about the backends? And we have another unit, load balancer discovery unit, which does that. So there's a fair amount of shell scripting here. And similar to a backend discovery unit, using binds to and after and conflicts option. So we tell Fleet to schedule this unit on the same machine the corresponding load balancer unit. And when the load balancer unit stops, this discovery unit also stops. And it starts only after the load balancer unit has started. And when before the unit starts, exec start pre option execute an inline shell script. And let's look into it. And it simply does the following. It takes all the backends that are already registered in etcd and adds them to NGINX Plus via its API. And let's go back. When the unit starts, with the exec start option, it launches the exec watch, etcdctl exec watch command, which lets us monitor the key, monitor etcd directory for changes, such as adding or deleting keys. And it can invoke a command when a change happens. And we pass two arguments to this command. The first one is the directory to monitor, and the second one is another inline shell script. And let me show it to you. So this is the script, which is not in light here. And etcd-ttl exec watch command passes the action to the script as a etcd watch action variable. And when the action is set, which means the key was added to the etcd, we just simply add the corresponding backend to NGINX. And when the action is delete or expire, which corresponds to the deletion or expiration of the key, we remove the corresponding backend from NGINX via API by making an API call. So let's look into the NGINX configuration file now. And we define a server that listens on port 80, and all the requests hitting the servers are passed to the upstream named backend. And as you can see, it doesn't have any service added yet. We're going to add them through the API. The add health checks is a special named location, which is also internal, which means you can't reach it from outside. And the sole reason we define it is for health checks of our backends. So we set 1 second timeouts so we can quickly detect the failure of the backend. And with using the health check directive, we define default health checks with 1 second interval. So NGINX default health checks make a request to each backend every 1 second and expect to the root location on the backend and expect the 2000 response to consider the backend as healthy. And we also defined another server, which listens on port 8081, where we expose our status API and our upstream conf API, through which we add in or remove in backends. So let's launch the backend service. Again, I put the commands in the script, so we're going to launch it instead. Let's see. So as you can see, it's scheduled on the machine with this IP address. So let me just copy it and open a web browser. So this is the page that is generated by our backend application. And you can see the host name of the container and an IP address of the container, of the backend container. And if we refresh the page, the response every time comes from another backend. And let's look into the NGINX Plus dashboard. And here we can see the live statistics about the NGINX. And we go to upstream tabs. And what we see here, all 3 backends were added, and they're healthy, they're green, which means that they are healthy. So what we're going to do now is we're going to destroy one of the backends. using fleetccl destroy command, we're going to destroy the backend number 2, as well as its corresponding backend discovery service. And let's go back to the dashboard. As you can see, backend was quickly removed from NGINX. What we're going to do now is we're going to suspend one of the machines, simulating an outage. So using let's run the list unit again. And we're going to suspend the machine number 2. Using vagrant suspend command, we can suspend the machine. So let's do it. NGINX, as you can see, quickly detected the outage. So now what's going to happen is 2 things. The first thing is that the unit on the failed machine going to be rescheduled on the healthy one. And the second thing is that the unhealthy backend is going to be removed from the NGINX after the 40 seconds of time to leave value when the key gets expired. So let's see if it's going to happen. OK. So I think it gets removed, and the healthy backend was also added. So, and that concludes our demo. Thank you. And Kevin, going to conclude the talk.
Yes, we got done a little quicker, but yeah, as you guys can see, this is kind of a cool way to do orchestration, using NGINX and CoreOS and some of the features that come inside already in CoreOS. What kind of questions can we answer about NGINX or possibly what we did today? I know it's a little involved and some of the scripts are kind of long, but does anyone have any questions? No one? No questions? No? Okay. All right. That's it. Thank you, guys. Thank you.